So me and Sam recently participated in our university's Game Jam event, Chef Jam 9. If you don't really know what a Game Jam is, you get a small amount of time to make a game from scratch, in this case 42 hours, based around a theme that's revealed when its time starts. So we arrived at university around 6 PM on Friday, and we got our stuff set up before the theme was announced at 8 PM to be villained, and we got to drawing up an idea. Our final design went like this: a local split-screen multiplayer game in which you play as two rival villainous sky pirates, trying to destroy the other person's airship. You use a cannon that you can set the angle and power of, and you figure out where to aim by looking at where projectiles are flying on the other person's screen. You can also place blocks to build defences and repair your ship, as the cannonballs can create holes. The way you would win is by either destroying the engine module, destroying the turbine module, making the enemy fall by destroying their ship so badly, or by directly hitting them. I got started by setting up the dual player controls using the new input system, which I've made a video on, link will be in the description. My idea was to make bindings on the keyboard for both WASD and arrows, then make a sort of input splitter that would go like this. I would have a central input handler that would respond to both WASD and arrows keyboard presses in the player input component, then in the player controller scripts, they would subscribe their own methods to the events they need. For example, the WASD player subscribes its move method to the WASD move events of the handler, and the arrow player subscribes move method to the arrow move events of the handler. It took a bit of time to configure, but getting it working gave me a nice foundation for movement. The next logical step forward was to implement interaction since I was doing controls. How I planned on doing this was to have an interactable base class, then if an object had a script for its interactions, it would inherit the interactable base class and implement the interact and leave interact methods. This would allow, say, a box to behave like a box and a cannon to behave like a cannon, but they would both strictly be interactable. This will be critical for the next stage. To detect the interaction itself, I would have a circular is-trigger collider for an object that was tagged as interactable object, and when the player collides with it, it would be added to a list of type interactable base objects. This is so that when I pressed E to interact, it would call the implemented interact method only on the closest interactable object. Then it was time for the Flappy Bird event. I didn't do very well. Anyway, this bit of logic ended up working nicely. As you can see here, I'm interacting with only the closest box. Having got an interaction to work, I went on to implement the cannon. The cannon was supposed to have 3 stages. Aiming, where when you interacted with it for the first time, it would bounce between 2 angles, then stop when you interacted again. And then power setting, where a power meter would go up and down and interacting would fire a cannonball at the power you stopped on. So this seems pretty straightforward. However, I'm apparently awful at making things rotate in Unity. And so for what seemed like an easy task, I had to try over and over and over and over and over and over again, until just when my grip on my sanity was about to slip, it finally worked. From here, I then just had to add the power meter, and then the cannonball firing mechanic. The firing was pretty simple, as all I had to do for it was instantiate a cannonball, then apply an impulse mode force onto it in the transform.right direction. In the meantime, Sam was working on getting the building to work. Building would work by a ghost block following you around on a separate tile map when you were holding a block to indicate where it would try and place. When you pressed E to interact, it would check if the tile on the actual world tile map the ghost block was pointing to was occupied, and if not, would set the tile to the block type you're holding. Next up, it was time to give the players some life, so I got to making the sprites for the 2 pirates, and since the theme was villains, the 2 pirates I went with were Davy Jones and Blackbeard. I wanted to make the characters in a very top-heavy way, so that their distinguishing detail could be shown in the face, and so that I could also include their big pirate hats. I left their bodies and legs very basic, since they would not be the centre of attention, and adding more detail to them would make the characters visually noisy. I also didn't include arms, since they weren't necessary, and I felt that they wouldn't suit the style I was making the characters in. Here's a side-by-side comparison with how they turned out, and honestly, I'm very happy with how they ended up looking. I also then made a simple walk cycle for both of them. Then there was a bit of fun bug fixing, after which I jumped in to make the split screen. It turned out to be a lot simpler than I expected of the level we needed, as all you have to do is parent one camera to the first player with these viewport settings, and another to the other player with these. And now you can see how the view shows the output of the 2 cameras for both players. In this time, Sam had made a tile set and built out the airships, as well as made some nice clouds for the background. He'd also used a single pixel smoothing shader to make the sky gradient. Since I was doing graphics and whatnot, I cooked up a nice sign to use as the UI for the main menu and added it to the game with simple button animations. I then added the sprites I had made for the characters and made the animations, which by the way was a start point for where handling player states was getting tedious, and it reminded me that I need to learn how to code a proper state machine. While I was doing this, Sam was working on the destruction element of the game. How it would work is that when a block was destroyed by colliding with a cannonball, there would be a check to see if it had caused the potential separation of the ship's tiles. If it did, it would run a depth-first search on the connected tiles of both potential separations of the ship's tile map, starting from the 2 blocks adjacent to the deleted block. If the 2 searches visited the same amount of tiles, then no full separation had been created. However, if the two separations visited a different amount of tiles, this meant that a full separation was made, and so it would delete the tiles that were visited by the shorter search. By the way, this video took a lot of effort to make, so if you're enjoying it so far, it would mean a lot if you left a like and subscribed. Anyway, moving on. We had the building mechanic working, however we needed to have a place from which the player would get blocks. This is what the interactable boxes would be for from earlier. We initially wanted a feature where if you dropped the stack you're holding, it would remain on the floor, similar to Unrailed. This would get too complicated and we just didn't have the time. This was the final design for the boxes. Each box would have a set capacity. When you interacted with it, you took 5 blocks. The capacity would reduce by 5 and your inventory went up by 5. However, if you then say placed 1 and interacted again, you shouldn't pick up 5 but 1. As well as this, if the box had say 3 blocks left and you have 0 in your inventory, you again should not pick up 5 but the remaining 3. We found a nice way to code this concisely. The increase in blocks would be the maximum value the player can pick up per interaction minus how many they are already holding. This value would be clamped to be minimum 0 and at maximum the number of remaining blocks in the box. This felt very nice in game, and getting this working made the game feel just a little bit more polished. Talking of polish, I then whipped up a smoke particle effect. Looking back I kinda messed up because smoke should expand the higher it rises, whereas mine fades out. This effect was made so that it would trigger when the generator or turbine was damaged. What would also trigger when the engine or turbine was damaged was a little UI indicator to alert the player to go fix it. I didn't go make any fancy UI elements for this because I wanted to save time, so I just made the UI icons using the sprites for the actual generator and turbine objects. Sam made and then exposed events so I could hook them up to the UI, and just like that, the UI was correctly indicating the status of each player's criticals. At this point it was getting late, or more accurately, early. However, I then reminded myself that tiredness is a social construct, and kept going. Currently, the jumping was very floaty and just felt really bad, and we wanted our movement in general to be more snappy. So what I had to do was make the jumping and falling acceleration faster. This again was a lot easier than I thought, as what you had to do was, if the player was falling, meaning their Y velocity was below 0, you increase the negative velocity by which they're falling. Then if they're going up and their velocity is above 0, you decrease their positive upwards velocity to sort of mimic stronger gravity. After coupling this with a stronger jump force and tweaking the other variables, I got very nice and snappy movement, which massively improved the feel of the game. I also went on to add being able to long interact, so there was a way for the player to delete their held blocks. This part was pretty difficult since I had not really researched a proper way to do this, so I had to hack something together in my sleep deprived state and weave it into my already suffering player controller code. Completing this, it was now 7:30 AM in the morning, and I had been up for 21 hours. This means I'd just experienced what it would be like in a day in the life of a Rockstar employee. However, the end was now in sight. The main thing I had to do now was implementing the fixing of the generators and turbines, so I went ahead of that, and luckily there was not too much fiddling around. I then added all the UI logic for the different game overs, which again was quick since Sam had made events to use for each of them. We then spent the last 2 hours of the jam applying finishing touches. Sam was working making sound effects, and he had made a sound manager system to make playing sounds from different parts of the code easy. In the meantime, I was working on making like the whole blimp part of the airship to make it look more like an actual airship. Then, finally, it was time to make a build. And thank the Lord, it built with no errors. We finished at 11:35 AM with 25 minutes to spare until the deadline. Then there was the judging and voting phase, and we were lucky enough to win the People's Choice Award. Here's a little showcase of how the final game turned out. When you load in, you're greeted by a lovely main menu and you can have a look at the controls like so. Then in the game you can see the cannon works as planned and the cannonballs even have a nice trail. Here I get hit with a good shot and you see a chunk of the ship get cut off, making my wood stash full, and the cannonball also hits my turbine. However, I can fix it with my metal block and the alert goes away, as well as the smoke. However, when I tried to go and rebuild that part with my metal blocks, I slipped and fell to my death. Sam also added a cool feature where you can move the ship up and down by interacting with the steering wheel. Then of course you can also build, as you can see here. However, maybe building yourself on a tall tower isn't the best strategy. At 2 PM the event finished, and so me and Sam went and devoured a Subway, then got home at 4 PM, at which point I took a shower, got changed, and fell asleep.